Hello students, welcome to AIMS India online classes. This is a chemistry session. We are going to discuss here about the chapter acids, bases and salts. From this chapter, we are going to see about different kinds of acids and bases and their classification based upon their properties. Acids, bases and salts are three important classes of chemical compounds. Yes, Uh, mostly the chemicals can be broadly classified into these three types: acids, bases and salts. These three are very important class of chemical compounds. Many of the food we eat and liquids we drink also contain certain acids and bases in them. Do you know this? Yes, the food items what we are taking and the drinks which we drink, these all may contain certain kinds of acids and bases in them also. So, with or without knowing, we are daily using these acids and bases, even salts also in our daily life. So, about this we are going to see now here. Acids and bases have been known by their properties since the early days of experimental chemistry. Yes, from the early days of science, they came to know about these acids and bases based upon their properties. For thousands of years, people have known that vinegar, lemon juice, and many other foods taste sour. Yes, they came to know about the food items like vinegar, lemon juice, some citrus juices. They taste sour. They came to know about this property even thousands of years back itself. It was discovered that these things taste sour because they all contain citric acid and ascorbic acid in them. So, at the earlier days itself, they found that these food items like these are orange or lemon juices or vinegar, they taste sour. Later on, they discovered that this sour taste of these food items is because of the presence of certain acids like citric acid and ascorbic acid. Acids belong to an important class of compounds. The word acid is derived from the Latin word acidus, which means sour. Yes, we told now these food items are being sour in taste because of the presence of acids like citric acid and ascorbic acid. So here the taste of acids is sour. As these acids are present in the food items, these food items also being tasted sour. All acids have one property in common. They are sour in taste. Mostly all the acids they taste sour. But don't try all the acids they are being sour. Don't try to taste the acids which are unknown to us. Some acids may be more dangerous also. Okay, some acids are not harmful, but some are dangerous and harmful. As we know the taste of these acids, we should not try to taste them in the laboratory also. Okay. Numerous acids occur in nature. We come across many acids in our day-to-day life also. Yes, with knowing or without knowing, we come across and we use so many acids in our daily life also. But we don't know as it is acid. In many food items we take in our daily life. Those food items also they may contain some acids in them. Oranges, lemons contain citric acid and apples contain malic acid. Lucius tomatoes are rich in oxalic acid. So tamarind and grapes they contain tartaric acid. Lactic acid is found in sour milk. See how many types of acids we are consuming daily without knowing, isn't it? Yes, these all food items they contain acids in them. Citric acid and ascorbic acid or these acids are present in some fruits like oranges and lemons. These fruits are called citrus fruits. And apples contain one of the acids malic acid. And tomatoes contain oxalic acid. And tamarind grapes these contain tartaric acid. And These sour milk and curd, they contain malic acid, lactic acid. Okay, in this way, the food items which we are taking, they are containing acids in them. How to classify these acids? Let us see here. The classification of acids based upon certain properties. One of them is based upon their sources. We told some acids now. From where they are available to us. Based upon that, acids can be classified into two types here. Based upon the source, acids can be classified into two types. One of them is organic acids. The acids derived from living things are called as organic acids. So, the acids which are derived from the living things like animals and plants are called as organic acids. For example, acetic acid, we told it is available in the form of vinegar. Citric acid or ascorbic acid, these two acids are available from citrus fruits like lemons and oranges. And formic acid, it is present in the stings of ants. Okay, so it is also having natural resource. Even tartaric acid, it is present in tamarind and grapes. In this way, and lactic acid present in the milk and sour milk and curd. These all acids derived from natural sources like living things like animals and plants. So these acids are called organic acids or natural acids also because their sources are from natural substances. Okay, one more category of acids based upon the sources is inorganic acids. The acids derived from the minerals are called inorganic acids or mineral acids. Okay, the acids which are prepared in the laboratory, we can say them also synthetic acids. The acids which are prepared in the laboratory or derived from the minerals like inorganic substances are called as inorganic acids or mineral acids. For example, sulfuric acid, of course, you may know this formula also. Sulfuric acid formula is H2SO4 and nitric acid HNO3, hydrochloric acid HCl. We might have heard these words frequently in our classes. We listen these words. Sulfuric acid, nitric acid, hydrochloric acid. These are acids which are prepared in the laboratory from the minerals. So such acids are called mineral acids or inorganic acids. So in this way, acids are classified into two types based upon their sources. If the sources are natural things like animals and plants, then those acids are called organic acids or natural acids. If the acids are derived from the minerals and they are prepared in the laboratory, then those acids are called inorganic acids or mineral acids. Okay. Next categorization on the basis of the strength of the acids. Based upon the strength also, acids are classified into different types. What are they? Strong acids. One of them is strong acids. The acids which undergo almost complete ionization in an aqueous solution. They are producing high concentration of H plus ions are called strong acids. What is the meaning of here? Ionization. Ion means we know charged particle. Ionization means formation of charged particles. So when you dissolve these acids into water, the molecules of acids separate into positive and negative ions. That means positive H plus ions and negative ions. This is separation of a molecule into positive and negative ions is called ionization. Almost all the acids they undergo ionization when dissolved into water. But the acids which ionize completely, almost all the molecules they split or separate into respective positive and negative ions. Then those acids are called strong acids. Okay, the acids which undergo almost complete ionization in an aqueous solution. Aqueous solution means the solution formed when dissolved into water. If you take certain quantity of acid and if you dissolve that into water, then that solution formed is called aqueous solution. Aqua means water. So water solution. When you add acid into water, it forms aqueous solution. In the aqueous solution, acids they split into positive H plus ions and negative ions. If an acid completely ionizes, if we dissolve 100 molecules of an acid into water, almost all the 100 molecules they split into H plus ions and negative ions. Then that acid is called strong acid. Example for the strong acids are nitric acid, HNO3, hydrochloric acid, sulfuric acid. These acids, when dissolved into water, almost all the molecules they ionize completely. Such kind of acids are called strong acids. For example, if you dissolve hydrochloric acid into water, it splits into H plus and Cl minus ions. In this way, positive ions and negative ions will be formed when dissolved into water. If you take strong acids like these, sulfuric acid, hydrochloric acid and nitric acid, when you dissolve them into water, the number of molecules whatever you have dissolved, almost all those will be ionized. So these acids are called strong acids. One more category of acids is weak acids. We told here strong acids means the acids which ionize completely. So opposite to that, the acids which undergo partial ionization means when very less number of acid molecules are ionized, most of the acid molecules are being as it is in the form of molecules, then those acids are called weak acids. See here definition is given. The acids which undergo partial ionization are less than 30% ionization in an aqueous solution are called as weak acids. The acids which undergo in less quantity are called weak acids. Example for the weak acids carbonic acid, acetic acid, formic acid, these all will come under weak acids. When you dissolve these acids into water, very few molecules of these will be separated into H plus ions and negative ions. Most of the molecules will be as it is like molecules only. So these are called weak acids. We can say one thing common here, almost all organic acids or natural acids we don't know. These all will come under weak acids only. All organic acids are weak acids. Even some more are shown here. Carbonic acid is also one of the weak acids. Okay, based upon the strength. Strength is nothing but the quantity of the number of molecules which ionize on dissolving into water. Based upon this, the strength of an acid is dependent. If almost all the molecules are ionized, then that acid is said to be strong acid. If very few molecules are ionized, then that acid is said to be weak acid. Okay, based upon the strength, two kinds of acids are there: strong acids and weak acids. Next, on the basis of concentration of an acid. What does it mean here, concentration? Concentration of an acid is said to be the measure of the amount of water present in a given sample of acid. Yes, based upon the quantity of water present in the sample of acid, its concentration is said. Okay, it is just the measure of amount of water present in the given quantity or given sample of acid. It is called concentration. Based upon the concentration or based upon the quantity of water present in the sample of acid, these acids are classified into two types again. So on the basis of concentration, acids are classified under two types. They are, one of them is concentrated acids. A sample of an acid which contains very little or no amount of water is called concentrated acid. So here the acid which contains more quantity of acid and very less quantity of water is called concentrated acid. The acid in which the quantity of acid is more is called concentrated acid. If the quantity of water is more than the acid quantity, then that is said to be dilute acid. An acid which contains far more amount of water than its own weight is called dilute acid. For example, if we take 1 liter of an acid, if it is containing 90 ml of acid and 100 ml of water, what is in this? The quantity of acid is more than that of water. Such kind of acid is called concentrated acid. More quantity of acid is there. So it is called concentrated acid. If we take another example, if we take 1 liter of acid, in that the quantity of acid is 200 ml and remaining 800 ml is water, then what it is called? Dilute acid, because there the quantity of water is very much larger than the quantity of acid. So that is called dilute acid. So in this way, based upon the quantity or amount of water present, acids are classified into two types: concentrated acids and dilute acids. One more, on the basis of basicity of an acid. What does it mean here, basicity? Basicity. Basicity of an acid. The number of hydrogen ions which can be liberated by one molecule of an acid on complete ionization in water is called basicity. Yes, we told while explaining about the strength of the acid. Acids on dissolving into water, they separate into respective positive hydrogen ions and negative ions. So based upon this, the number of hydrogen ions liberated from one molecule of an acid, its basicity is defined. The number of H plus ions liberated from one molecule of an acid is called its basicity. Okay, basicity means the number of hydrogen ions liberated from one molecule of an acid. For example, if you take hydrogen chloride, HCl acid, when you dissolve this hydrochloric acid or hydrogen chloride acid into water, that splits into H plus ion and Cl minus ion. Here, one molecule of hydrogen chloride is producing one H plus ion. So, based upon this number of H plus ions produced from one molecule of that acid, it is said to be its basicity. The basicity of hydrogen chloride is 1, because one molecule of hydrogen chloride giving 1 H plus ion. Okay, that is called basicity. The number of H plus ions furnished or liberated from one molecule of an acid. So based upon this basicity, acids are classified into different types. Out of them, the first one is monobasic acids. We know mono means one. Monobasic acids means the acids which produce or which liberate one H plus ion from its molecules on dissolving into water are called monobasic acids. When one molecule of an acid on complete ionization produces one hydrogen ion, then the acid is called monobasic acid. Okay. Example, if you see hydrochloric acid, acetic acid, formic acid, nitric acid, these are the different acids which produce only one H plus ion from its molecule. As we said, if you take this HCl, when you dissolve this HCl into water, what happens? This HCl molecule ionizes or separates into respective ions. So from each molecule of hydrogen chloride, hydrochloric acid, one Cl minus ion is produced. How many? 1. So from one molecule, only one H plus ion is produced. So it is said to be the basicity of hydrochloric acid as 1. Such kind of acids are called monobasic acids. Even this nitric acid also, it produces one H plus ion and one nitrate ion, NO3 minus ion. In this way, these acids, they produce one H plus ion from each molecule of it. Such kind of acids are called monobasic acids. Next, dibasic acids. When one molecule of an acid on complete ionization produces 2H plus ions or 2 hydrogen ions, then the acid is called dibasic acid. Yes, certain acid molecules or certain acids are dissolving into water. They produce 2H plus ions from each molecule of it. Such kind of acids are called dibasic acids. For example, sulfuric acid, carbonic acid. These acids on dissolving into water from each molecule 2H plus ions or 2 hydrogen ions are being liberated. For example, if you dissolve this into water, it produces 2H plus ions and sulfate ion, SO4 minus 2 ion. So what is happening here? The sulfuric acid on dissolving into water, from each molecule 2 H plus ions are liberated. This kind of acids are called dibasic acids because they have basicity 2. What does it mean here? Basicity means the number of H plus ions liberated from each molecule of it is called its basicity. So they are called dibasic acids. Even carbonic acid also in the same way. Next, one more kind, tribasic acids. The acids which produce 3 hydrogen ions from each molecule on complete ionization are called tribasic acids. For example, phosphoric acid. This phosphoric acid H3PO4 on dissolving into water, this produces 3H plus ions and 1 phosphate ion. PO4 minus ion will be formed. So in this way, each molecule of this phosphoric acid produces 3H plus ions. So these kind of acids are said to be having basicity 3 because from each molecule 3H plus ions are produced. These are called tribasic acids. Okay, the acids which produce 3H plus ions from each molecule are called as tribasic acids. Phosphoric acid, phosphorus acid, etc. Okay. Next, bases. Till now we have seen the classification of acids based upon certain properties. In the same way, we are going to see now about bases. Bases are the metallic oxides or hydroxides which react with acids to give salt and water. Yes, mostly these metallic oxides and metallic hydroxides are bases because they react with acids and produce salt and water. Bases that are soluble into water are called alkalis. Yes, the bases which are soluble into water are called acids. There are different kinds of bases, but all the bases are not soluble into water. Especially those bases which are soluble into water are called alkalis. Especially, for example, sodium hydroxide, potassium hydroxide, calcium hydroxide are soluble into water. Yes, these acids are fairly soluble into water. So these are said to be alkalis. But there are some bases like copper hydroxide, ferric hydroxide, iron hydroxide, aluminum hydroxide. These bases they do not dissolve in water. Even though they are bases, they do not dissolve into water. Such kind of bases are not called alkalis. Okay. So the bases which are soluble into water only called as alkalis. So we can say hence all alkalis are bases, but all bases are not alkalis. Yes, out of all kinds of bases, some are soluble into water, some are not soluble into water. Those bases which are soluble into water are called alkalis. So we can say all alkalis are bases, but all bases are not alkalis. Okay. Next, the classification of bases also let us see here based upon certain properties like how we have seen in the case of acids. Here, based upon the strength of bases, strength means what we said, the content which dissociate, the quantity of a substance which dissociates into respective ions on dissolving into water. Based upon it, its strength is decided in the acids and bases. So here, bases also classified into two types based upon their strength. One of them is a strong bases. The bases which dissolve completely or which dissociate completely in aqueous solution to produce high concentration of OH minus ions are called strong bases. OH minus ions are called hydroxyl ions. We know bases contain OH ions in them. How acids are having H plus ions in them, bases are also having OH minus ions in them. For example, sodium hydroxide we said NaOH. When this base is dissolved into water, the molecules of this base will separate into positive metal ions and OH minus ions. These OH minus ions are called hydroxyl ions. So the base which completely ionize to produce more number of OH ions are called strong bases. For example, sodium hydroxide as I said and potassium hydroxide, these they produce more number of OH minus ions. If you take 100 molecules of sodium hydroxide into water, almost all the molecules they split into Na plus ions and OH minus ions. So these bases are said to be strong bases which ionize completely, which is separate into respective ions completely. Okay, next one. Next category, weak bases, quite opposite to this. The bases which undergo partial dissociation in an aqueous solution so as to produce a low concentration of hydroxyl ions or OH minus ions are called weak acids. Yes, some kinds of bases are there. When you dissolve them into water, very few molecules will dissociate. Dissociate means splits into ions. Very few molecules they separate into respective positive and negative OH ions, OH minus ions. Such kind of bases are called weak bases. For example, ammonium hydroxide, calcium hydroxide. These, when you dissolve them into water, very few molecules of those will split into OH minus ions and positive ions. Okay, based upon the ionization, bases are classified into two types, strong bases and weak bases. Okay, next, on the basis of concentration, yes, these bases also classified in different types based upon the concentration. What is the meaning of this concentration? We say concentration means the presence of the quantity of water present in the given sample of base is called concentration. The measure, yes, the measure of the amount of water present in an aqueous solution of a base is called the concentration of that base. Based upon the concentration, bases are classified into two types. They are concentrated bases. The base solution which is having a relatively high concentration of or high percentage of base in its aqueous solution is called a concentrated base. Means base which is containing more quantity of base than water. If the water quantity is very less than that of base quantity, then that base is said to be concentrated base. One more classification, dilute base. A base solution having a relatively less percentage of base or alkali in its aqueous solution is called dilute base. So, in a base, if the quantity of water is much more larger than the quantity of base or alkali, then that base is said to be dilute base. Here, the word dilute or dilution represents addition of water. So the dilute base means the base which contains more quantity of water in it than the quantity of base. It's called dilute base. On the basis of acidity of a base. What is the meaning of acidity here? Let us see. Acidity of a base is defined as the number of hydroxyl ions furnished or liberated by one molecule of a base on complete dissociation in water is called acidity of the base. Yes, the number of hydroxyl ions or OH minus ions furnished by one molecule of a base on complete dissociation in water is called acidity of the base. So based upon this acidity, bases are classified into two types. They are not the three. There are more than two types are there. One of them is monoacidic bases. The bases which furnish only one hydroxyl ion per molecule when dissolved into water are called monoacidic bases. For example, sodium hydroxide. When you dissolve the sodium hydroxide into water, it produces only one hydroxyl ion from each molecule. Such kind of bases are called monoacidic bases. One more example, lithium hydroxide. When you dissolve this lithium hydroxide into water, it splits into Li plus and OH minus ion. So from one molecule of lithium hydroxide, only one OH ion is produced. This kind of bases are called monoacidic bases. Diacidic bases. The bases which furnish two hydroxyl ions per molecule when dissolved into water are called diacidic bases. For example, calcium hydroxide. Its formula we know CaOH taken twice. When it is dissolved into water, from each molecule of calcium hydroxide, two OH minus ions are produced. So this kind of bases which furnish two hydroxyl ions from each molecule are called diacidic bases. One more example, magnesium hydroxide. Here also you see two OH minus ions or two hydroxyl ions are produced from each molecule of magnesium hydroxide. So it is also diacidic base. Next, triacidic bases. A base which furnishes two hydroxyl ions per molecule when dissolved into water are called triacidic bases. The bases which produce 3 OH minus ions per molecule are called triacidic bases. For example to this, aluminium hydroxide, AlOH taken thrice. When you dissolve this aluminium hydroxide into water, it produces 3 OH minus ions and Al plus 3 ion. So there are 3 OH minus ions, produces 3 hydroxyl ions. Even ferric hydroxide also in the same way. It produces 3 hydroxyl ions when dissolved into water. So these bases are called triacidic bases. Okay. Thank you for watching our video. Please visit our website aimstoday.in for latest updates and recorded videos. Thank you.